Let's continue with hot extrusion. As the name implies, in this one, we increase the temperature of the billet so that with less forces we can do the process, and it's most preferred for materials having less ductility at the room temperatures. But the thing is that we should be careful about high temperatures, since once the temperature is higher, then you may have too much wear on the die, too much wear on the RAM. So these are important issues. And another thing, the resulting workpiece may have non-uniformity on the surface. Its quality will be low. So we need to consider these issues and then try to find maybe other ways. And another thing, if you want to improve the performance of hot extrusion, as we have done in the isothermal forging process, we can also heat the dies so that there will be less temperature difference between the die and the billet, and this will result in a bit better surface quality. Another issue is that, as in the case of hot forging operations, if you are not performing this extrusion process in inert atmosphere, you have oxide films all around, and they may be quite abrasive, and the workpiece surface quality will be decreased. So what we do in order to solve this issue, we have a simple solution for that. Let me annotate that one. So assume that this is your die opening, and assume that this is our, let's say, workpiece billet to be extruded. And let me use another color for the RAM. What we do, we make use of it actually a bit smaller diameter RAM. So once you push this RAM onto the workpiece, then what will happen? These sides actually will not be extruded, okay? And this is actually the thing we want to have, since these are oxide films. So once you use a smaller RAM, these will not be extruded, and we will have high quality workpiece at the end of extrusion. And these oxide films will be remaining inside the chamber. And once the process is over, you can remove your RAM and clean the chamber. With this way, the quality of your workpieces will be improved. And furthermore, with this process, we can even produce tubes. What we need to do, we may use some mandrels, and we can do this process by using actually solid or hollow billets. This is an actually hollow billet, as you see. The center of your billet material, the workpiece is empty. We have an opening there, so we push our mandrel into that. And since there's a clearance between the mandrel and the die walls, so once we apply force from this left side, we will be producing a seamless tube. Another case, if you want to use actually a solid type of billet, then you may use a kind of a spider kind of, let's say, die. And again, since there's an opening between this central mandrel and the die surface, we will obtain a tube shape after this extrusion process. And as in the case of other metal, let's say, operations, manufacturing operations, lubrication is highly important. It's especially important in hot extrusion. With the help of it, material can flow easily with less forces. The quality of the surface quality will be much better. The surface integrity will be better. And as I said, we will be using less forces to do the extrusion process. And we know that for the steels, for metals, glass is a highly popular type of lubricant. So it's actually protecting the metals from the surface of the container and the die. And these are some example products. You see they all have 2.5D shapes. Even though they have thin walls, they can easily be extruded. Now let's have a look at cold extrusion. As the name implies, we are performing this operation at room temperature. And the thing is that it's actually a combination of direct, indirect, and sometimes forging operations. So we cannot clearly state that cold extrusion can only be done with direct extrusion or with only indirect, but it's a combination of direct, indirect extrusion and forging processes. So we have an example here, you see in this first one. we are pushing it to our punch onto this workpiece, and then some material will be extruded, as you see, in that way. And we have a backing at this bottom side so that it keeps actually controls the dimension of the workpiece. And here things are a bit different. We have two punches this time, so which means that they're both moving. The bottom one is moving upwards and the upper one is moving downwards. And with the help of this relative motion, we have different material flow. So you see we have material flow over the punch surface and material flow also into the punch. So this is the process actually highly depending on the design of the punches, design of the die. And in summary again, it's simply a combination of direct extrusion, indirect extrusion, and forging. What are the advantages compared to hot extrusion? First of all, since the temperatures are not high, the dimensional traversals, dimensional accuracy is much better. The surface quality is again high, since again the temperatures are low. Don't have any, let's say, deformation on the surface. We don't actually generate an oxide film over the surface. So with the help of them, the quality, the surface finish, dimensional accuracy are much better. Another thing, we have improved mechanical properties like the strength, since we have the case of work hardening and the size of the grains are decreased. But the thing is that you should be careful about friction. If you have too much friction, then this may increase the temperature of your workpiece, and if it is increased, then you may start recrystallization. If that is the case, then it will be a kind of an hot extrusion process. Another issue, the production rates are quite competitive with other processes, so depending on the numbers, depending on the shape of your design, you may follow cold extrusion or other types of processes. The only difference is that this time we have impact forces, and this happens in some seconds, but the rest is the same. You see, we have initial blank material, and with the help of impact force, the side surfaces are actually extruded through this clearance in between the punch and the die surfaces. And depending on your die design, you may even have such complicated, much complicated workpieces. The advantage is that you can produce such a complicated shape in some seconds, which is not possible to obtain actually by using different manufacturing processes. We already discussed hydrostatic extrusion, so I'm not going to discuss it again, but keep in mind that we are using incompressible fluids so that the pressure can easily be transferred from the ram onto the workpiece. And we usually do it at room temperature. We don't want to increase the temperature of the fluid and the material and the die. Now let's have a look at the second main part of this chapter, the drawing process. As I said many times, this drawing is actually highly similar to extrusion. The only difference is that we are pulling the material from the die opening instead of pushing it from the back side. And we can use similar dies you see. It's almost the same, just we mostly have smaller die angles. And again, we have ratios in between initial cross section and final cross section. And again, same relief angle is also present in drawing process. So how we are doing it? Obviously, we need, in order to start this process, you need to actually maybe do a little machining and then push your actually workpiece into this die opening and then grab this workpiece from the other side. Since without doing this operation, without decreasing this temperature, for instance, you cannot start the processes. Your, let's say, gripper cannot grip this tip of the material. That's an important issue, a simple but an important issue in drawing process. In the drawing, you can also produce some tubes, not wires or bars, but we can produce some tube shapes. And on the material, the shape, or depending on the decrease in the diameter, you may need to use mandrels, or without mandrel, you can even do tube drawing operation. And like in the case of, again, extrusion processes, if you want to increase the die log, if you want to do this drawing process at lower forces, you need to use some lubricants in this process. The surface quality will improve again. With less forces, you can complete the process, and there will be less increase in the temperature. So how we can do this application? That drawing, this is actually a very simple one. All are full of lubricants, or you may do the box, and we don't equivalent pool, but instead just cover the surface of our workpiece. Or we may do metal coating. In this one, we make use of metal like or tin around the wire is coated, and with the help of it, again, the temperature